Hello students, welcome to my channel SUNEEL PURWAR. In today's class, I am going to discuss a very important concept of quadratic equations known as the relation between the roots and the coefficients of a quadratic equation. Before I begin the discussion, let me introduce myself. I am SUNEEL PURWAR. I have been teaching maths for 20 years and several of my students have got ranks in top 100 of IIT Advanced Exam and JEE-Mains, with best rank being All India rank 1-3 in the Advanced Exam, okay, and All India rank 5 in JEE-Mains there. Both the ranks are in open category, okay. So when I said the ranks in top 100, they meant to be the ranks in open category, okay, All India ranks in open category. Now let me start the discussion on quadratic equations with the concept of relation between the roots and the coefficients. So before I take up the questions, let me tell you the important things in this discussion. Now, first of all, an expression of the form ax square plus bx plus c. Okay, so I have put the arrows there. Alright, so an expression of the form ax square plus bx plus c is called a quadratic expression. Alright, why we are calling it quadratic? Because in this expression the highest power of x is how much? 2. So when in an expression the highest power of x is 2, it is called a quadratic expression. Now the coefficient of this highest power of x is a. Alright, so this coefficient of the highest power of x is called the leading coefficient. I repeat, what is the meaning of leading coefficient? The coefficient of the highest power of x. Right now in this expression, the highest power of x is what? 2. Okay, that means x square. What is the coefficient of that? A. So a will be called what? Leading coefficient of the expression. Now in this quadratic expression there is a sum of 3 terms. Okay, first term plus second term plus third term. Okay, so an expression of this type is called trinomial. Okay, so this is a quadratic trinomial. So sometimes we may call it what? Quadratic trinomial as well. Okay, or quadratic expression there. Now when a quadratic expression is equated to 0, alright, what you get is called a quadratic equation. Okay, so this is a quadratic equation, ax square plus bx plus c equal to 0. So for this equation to be quadratic, obviously x square must be there. Right? So to ensure that a must not be equal to 0. Understood? So in short, in a quadratic expression, leading coefficient can never be 0. Okay, a is the coefficient of what? X square, that can never be 0. Leading coefficient can never be 0. Now here I have listed on the board 5 very important points which will be needed frequently to solve the questions. With the statement, if alpha and beta are, or if alpha and beta be roots of the quadratic equation, okay, this quadratic equation, then so what is the meaning of root? The meaning of root is it will satisfy the equation. So if you say alpha is a root, now this is a quadratic equation in what? X. What is the unknown variable here? X there. So be clear, this is a quadratic equation in X. If you want to say a quadratic equation in Y, what will you say? AY square plus BY plus C. Alright. So if alpha beta be the roots of this quadratic equation, so what is the meaning of roots? They satisfy the equation. So the number alpha and number beta, they will satisfy the equation. So that is our very first point. So that means if you put x is equal to alpha, this equation will be satisfied. So put x is equal to alpha. What do you get? A alpha square plus b alpha plus c equal to 0. A alpha square plus b alpha plus c is equal to 0. Similarly, as beta is the root, so put x is equal to beta. Equation will be satisfied. A beta square, so put it there. A beta square plus b beta plus c equal to 0. Okay, so what is the first point? The numbers which are roots have to satisfy the equation. That's why they are being called roots. Okay, so roots, what is the first duty of the roots? To satisfy the equation. So if you say the numbers alpha and beta are the roots of this quadratic equation, that means they have to satisfy the equation. On satisfying them, you get this for alpha and this for beta. Second point, what are the values of those roots? Alpha, beta. Minus b plus minus under root b square minus 4ac upon 2a, where the quantity b square minus 4ac is called discriminant of quadratic equation, frequently denoted by capital letter D. What is it called? Discriminant of the quadratic equation. Now, so there are two values here, one with the plus sign. If you take plus sign, you will get one root. If you take minus sign, you will get another root. If you add both the roots, okay, you will get what? Sum of the roots. So sum of the roots is given by sum of the roots. What are the roots? Alpha, beta. So sum of the roots alpha plus beta is equal to minus b by a. This is the formula. What is the interpretation of this formula? With a minus sign, b stands for coefficient of x. B stands for coefficient of x. Divided by a. A is the coefficient of x square. Alright. So minus of this ratio, coefficient of x divided by coefficient of x square will give you what? The sum of the roots. On the other hand, product of the roots. Roots are alpha, beta, so their product alpha into beta is given by this formula c by a. What is c? Constant term. This was a quadratic equation in x, so this term which is without x, will be called constant. So c means what? Constant term divided by a, which is coefficient of x square. Okay, so this is the formula for what? Sum of the roots, and this is your formula for what? Product of the roots, c by a, and sum is what? Minus of b by a. And the last but not the least, okay, equally important concept is, if you say alpha, beta are the roots of the quadratic equation, this quadratic equation in x, okay, that means on putting x is equal to alpha, you get 0. On putting x is equal to beta, you get 0. Okay. Meaning of roots means what? LHS will be equal to RHS on putting the roots. So, if alpha, beta are the roots of the quadratic equation, this quadratic equation, then the corresponding quadratic expression, this is quadratic equation. And what is the corresponding quadratic expression? This thing. See from this arrow to this arrow. Ax square plus bx plus c is the corresponding quadratic equation. So that corresponding quadratic expression ax square plus bx plus c will be equal to what? Product of x minus alpha, x minus beta and a, that is leading coefficient. Okay. This we can write from what? Factor theorem. You remember factor theorem, that if x is equal to alpha is a root. Okay, if alpha satisfies the equation, if alpha satisfies a polynomial equation, then x minus alpha will be a factor. Remember, if x is equal to alpha is a root of a polynomial px equal to 0, then x minus alpha will be the factor. So for this quadratic expression, x minus alpha will be a factor because alpha is a root, beta is a root, so x minus beta will also be a factor. Okay, and so you see, if you just multiply these two, what you will get? X square. So coefficient of x square is what? 1. But in actuality, in the quadratic expression here, coefficient of x square is given to be a. So for that reason, we need to multiply with a as well, so that both the sides remain equal. Understand? So this is the very important concept there, which we are writing with the help of factor theorem. In a quadratic equation, if alpha, beta be the roots, then the corresponding quadratic expression is equal to what? Product of these two factors using the roots, x minus alpha and x minus beta, alright, with multiplied with a. Then see this question. If alpha, beta be the roots of this quadratic equation, 2x square minus 35x plus 2 equal to 0, then you have to tell this value. Okay. So here we are going to use the very first point. If alpha beta are the roots means they have to satisfy the equation. So the number alpha and beta will satisfy this quadratic equation as I had told you in the first point. So root alpha implies you will get 2 alpha square minus 35 alpha plus 2 equal to 0. Now from here you can take alpha common. So you will see 2 alpha minus 35 plus 2 equal to 0. Alright. That means this quantity 2 alpha minus 35 is equal to, take this to another side, so it will become minus 2 divided by this alpha. Similarly, so say this is 1, relation 1. Now in place of alpha, in a similar way if you put beta, okay, beta is also the root, you will get 2 beta square minus 35 beta plus 2 equal to 0. Okay, so beta implies 2 beta square minus 35 beta plus 2 equal to 0. And in a similar way, you will get 2 beta minus 35. Alright, take beta common. So 2 beta minus 35 plus 2 equal to 0. That means That means 2 beta minus 35 is equal to minus 2 by beta. This will become minus 2 on other side, so minus 2 by beta. Let's say this is a relation 2. So these are the two relations we have got, 2 alpha minus 35 and 2 beta minus 35, their values. Okay. Now go back to the question. This is the required value we want. So as the exponents are same 3 3, alright, so their bases will get multiplied. So the required value we can write as whole cube of product of 2 alpha minus 35 and 2 beta minus 35. 2 alpha minus 35, 2 beta minus 35, their product. Reminding you, alpha to the power m into beta power m. When the two exponentials are having the same exponent, okay, what happens? You will have the product of base raised to the same exponent. Alright, so same exponent will continue and the bases will get multiplied, product of the bases. So that's what you have. Now, so this is equal to whole cube of, now 2 alpha minus 35. From the first relation, 2 alpha minus 35 is nothing but minus 2 by alpha, put it there, minus of 2 by alpha. And 2 beta minus 35 from second relation is equal to what? Minus 2 by beta. Minus 2 by beta. So you see what you have inside the cube. So required value is equal to whole cube of, see these quantities inside the bracket. How we got this minus 2 by alpha? From this relation 1. 2 alpha minus 35. In place of that we can write minus 2 by alpha. Then similarly from this second relation, 2 beta minus 35 is equal to minus 2 by beta, that we have put. So what is the product of this? 4 upon alpha beta. 4 upon alpha beta. That means alpha into beta, product of the roots, for which what is the formula? C by A, product of the roots, alpha beta. So you see from this quadratic equation, the product of the roots is equal to C by A, constant term. constant term which is 2 divided by coefficient of x square. What is the coefficient of x square? That is also 2. So this product of the roots is nothing but 1. So this product of the roots alpha beta is 1. So your answer is what? 4 upon 1, which is 4 only, whole cube, which is 64. So that's your answer, 64. This question says, if roots of the quadratic equation x square minus 2bx plus c equal to 0 be two consecutive odd integers, then what is this value of b square minus c? Now in your mind you bring any two odd integers, say 1, 3. What is their difference? 2. If you do 1 minus 3, that is minus 2, but mod value will be what? 2 only. Mod of minus 2 is 2. And if you do 3 minus 1, in that case also mod value. So this 3 minus 1 means 2, mod of 2 is 2. Similarly, you think of any two consecutive odd integers. You will see the mod value of their difference is what? 2. So if you say one of them is alpha, another is beta, so another root is beta. Two consecutive odd integers, they are the roots. Two consecutive odd integers, say 1, 3, for purpose of understanding. Call them alpha beta. So what you notice? Mod of alpha minus beta is equal to 2. So this is the purpose of this information. When you say two consecutive odd integers are the roots, it means mod of the difference value is 2. Mod of alpha minus beta equal to 2. You can try with another pair also, say 7 and 9. What is the mod value of their difference? 7 minus 9, mod of minus 2, which is again 2. Or even if you do mod of 9 minus 7, the value is what? 2. Understood? So, why we are using modulus? Because in one case, the difference will be minus 2. In other case, the difference will be plus 2. In this case, what is the difference? When you do smaller root minus bigger root, the difference is minus 2. And when you do bigger root minus smaller root, the value is what? 2. So, to remove this difference, once we are getting minus 2, another time we are getting plus 2, we are using what? Mod. Because whether you find mod of minus 2 or mod of plus 2, in both the cases that value will be what? 2. I have shown you here as well. Okay. So what is the meaning of this information? That if you say the roots are alpha beta, okay, then mod of alpha minus beta will be 2. Do squaring on both sides. Alright, so this square equal to what? Square of this equal to 2 square, which is 4. Now, you can recall mod of x whole square is nothing but x square. So, using this property, you can think this as x. So, square of mod x, you can write as what? Simply x square. What is that x? Alpha minus beta. Okay, in place of x, what you see? Alpha minus beta. Compare with this property. Equal to 4. Now, open the square. Alpha square plus beta square minus 2 alpha beta equal to what? 4. Now, this thing you can write as alpha plus beta whole square minus 4 alpha beta. Is it or not? See, they both are equal. So this is the trick whenever you are dealing with what? Difference of the roots, alpha minus beta. Okay, so what you do? Alpha minus beta whole square. Got that? So alpha minus beta whole square, if you do the squaring, is equal to this squaring formula. Okay, and if you open this square, what you get? Alpha square there plus beta square there plus 2 alpha beta, and this minus 4 alpha beta, what is the resultant then? Plus 2 alpha beta from here and minus 4 alpha beta will make it what? Minus 2 alpha beta. Okay, so directly you can, from next time you can directly write square of alpha minus beta is equal to what? Alpha plus beta whole square minus 4 alpha beta. So whenever a question involves difference of the roots, okay, say alpha minus beta, then you can use this as an identity for the purpose of simplification. Got it? Now you see, what's the benefit of change from this step to this step? Now we can write down all these values using what? Formula for sum of the roots. Alpha plus beta is what? Sum of the roots. Okay. This is our equation. This is our equation. What is the sum of the roots? Sum of the roots is 2b, square of it. Use these formula for sum of the roots and product of the roots, minus 4 times alpha beta, product of the roots, okay, constant term c upon leading coefficient 1, c by 1, that is c only, is equal to 4. Now that means 4b square minus 4c equal to 4. So you can cancel 4 on both sides and you are left with b square minus c equal to 1. That's your answer. That's your answer. So in this question you have come across 2 important points. One was when question says something like 2 consecutive odd integers, means mod value of their difference is always 2. Second thing is, whenever a question talks about difference of the roots, and it has appeared here, okay, so square of the difference can be written as this, using sum of the roots alpha plus beta and product of the roots alpha into beta. Okay, so these are the 2 things which have been illustrated through this question, and they will be useful for other questions as well. See this question: if the sum of the roots of this quadratic equation is 6, then find the product of the roots. So first of all, some of you may not understand how this is quadratic equation. You simplify this equation, okay, like terms. So x square, you club them together, so you will have what? 5 plus 4k into x square. Total how much x you have? Minus 4x, alright, and then minus 2kx, alright. So combine the like powers of x. Constant term, how much? 2 plus k into 1, k, 2 plus k equal to 0. Now the question says sum of the roots is 6. Let's say the roots are alpha beta, so alpha plus beta is equal to 6. This is given to us. Now write down alpha plus beta using the formula. So that will be what? Minus of b by a is our formula. So minus of, what is b? Minus of 4 plus 2k, minus of b by a, and what is that b? Itself with a minus sign. So minus of 4 plus 2k divided by a, which is 5 plus 4k, and that is given to be 6. Now simplify this equation, so it becomes plus sign, alright, simplify. So 4 plus 2k is equal to, take it on other side, so that will become 30 plus 24k. Now if you simplify this, that will become 22k equal to how much? Minus 26. 4 minus 30. So what's the k value? Minus 13 upon 11. So k value is minus 13 by 11. K equal to minus 13 by 11. Now what we have to find? Product of the roots. So product of the roots formula: alpha into beta, product of the roots, c by a is the formula. So as per this formula, what will you write? Constant term 2 plus k divided by the leading coefficient, okay, which is 5 plus 4k. So this is the value for what? Product of the roots. Now you have already got the value of k from the given condition. Sum of the roots equal to 6. So put this value of k over here and do the calculation. So that is 2 minus 13 by 11 divided by 5 minus 4k. Okay, so sorry, 5 plus 4k. So 4k will become how much? Minus 52 by 11. So if you simplify this, 9 by 11 upon 3 by 11. Which is equal to 3. That's your answer. In this question, the information is if 3 is a root of this equation, quadratic equation, then what is the other root? Now, as this number is a root, it will satisfy the equation. So, once you satisfy this equation, you will have what? Put x is equal to 3. You get 9a plus, put x is equal to 3, continue to put 4 into 3, 12 plus 5, 17. Alright. So from here, what is the a value? Minus of 17 by 9. Now the question is asking you the other root. Now this root name I can say alpha, say 3, and other root is beta. So as per our knowledge, product of the roots alpha beta is equal to c by a. What we have? C5 upon a. Now alpha value is 3. So you can find the value of other root 5 upon a, and what is a itself? Minus 17 by 9. Minus 17 by 9. So from here you will have beta equal to, do the calculation, minus 15 by 17. That's your other root. Now the question says, if one root of this equation minus x square plus 7x minus 7 is equal to m minus x be 3 times the other root. So you have to tell the value of m. Now first of all, you can rewrite this properly in the form of a quadratic equation, ax square plus bx plus c equal to 0, that form. Okay, so take everything on this LHS to RHS. You will get x square, and this will become what? Minus 8x, and this will become what? 7 plus m equal to 0. Now if you say one root is alpha, and question says one root is 3 times the other root. So if you say one root is alpha, then other root will be 3 times, means 3 alpha. Okay, that's the question has informed us. Now, so roots are alpha and 3 alpha. Now, what is their sum? Their sum is alpha plus 3 alpha, 4 alpha. And you know, formula for finding sum of the roots, minus b by a. So from that formula, what is the sum? 8. The sum is what? 8. So alpha value is 2. Now, so if alpha is equal to 2, what are your roots? You immediately get both the roots. Alpha is equal to 2 means one root is 2 and other root is 3 times, means what? 6. So roots are 2 and other root is what? 3 to the 6 there. Now you see, what is the product of the roots here? Product of the roots is product is 12, and from this equation, product of the roots, you know the formula, c by a will give you 7 plus m, coefficient of x square 1. So constant 7 plus 1 m, constant 7 plus m divided by leading coefficient 1. So straight away you get the answer, m equal to 5. If alpha beta be roots of the equation 3x square plus 6x plus 2 equal to 0, then you have to find this value, 1 upon alpha plus 2 whole cube plus 1 upon beta plus 2 whole cube. Alright, this value you have to tell. Now, as alpha beta are roots of the equation, they will satisfy the equation. So put x is equal to alpha. This is a quadratic in x, so x is equal to alpha will satisfy, and x is equal to beta will also satisfy, as they are the roots. So you get, on satisfying alpha, what you get? 3 alpha square plus 6 alpha plus 2 equal to 0. And similarly, if you satisfy beta, you will get 3 beta square plus 6 beta plus 2 equal to 0. Now, you can take 3 common from this and you can take in fact 3 beta common. So if you take 3 beta common, what is left? Beta plus 2. Alright, plus 2 equal to 0. That means 3 beta into beta plus 2 is equal to minus 2. Okay, and that means beta plus 2 we can write as what? Minus 2 upon 3 beta. Alright, minus 2 upon 3 beta. Now you see, in these two relations there is only one difference, that in place of alpha there is what? Beta. So in a similar way, if you simplify this relation, you will have, so let's say this is information 1, and if you simplify this part, this relation in a similar way, what you will get? Alpha plus 2. In place of beta, what is there? Alpha. So you will have alpha plus 2 is equal to minus of 2 upon 3 alpha. Okay, say this is relation 2. Now let's come back to this required value. This is the required value, 1 upon alpha plus 2 whole cube plus 1 upon beta plus 2 whole cube. Alright, so substitute alpha plus 2. How much is that? Minus 2 by 3 alpha whole cube. Similarly, substitute beta plus 2, which is minus 2 upon 3 beta whole cube, which will become, on cubing this will give you what? Minus 8. Okay, and this will become what? 27 alpha cube. Alright, so it goes up as 27 alpha cube upon what? Minus 8, and this will become 27 beta cube upon minus 8. So in fact, you can take this number, which is minus 27 by 8 common, minus 27 by 8, and what is the remaining part? Alpha cube plus beta cube, alpha cube plus beta cube. Now here we will use an identity that alpha cube plus beta cube can be written as. Okay, so all of you are aware of this formula of cubing, that alpha plus beta whole cube is equal to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta. So time to use that formula. So as per this formula, okay, let's do the calculation. Alpha plus beta, sum of the roots. So what is sum of the roots? Minus 6 by 3. Okay, so from here sum of the roots, alpha plus beta is equal to minus 2 minus b by a, which will give you what? Minus 2, and product of the roots is what? C by a, 2 by 3. Product of the roots alpha beta is equal to 2 by 3. Then put these numbers over here. So minus 2 whole cube will become minus 8 is equal to, this is the required value needed here, and 3 times product of the roots, which is 2 by 3, and alpha plus beta is already minus 2. So you see, what is this value finally here? Minus 4. So alpha cube plus beta cube, this value is equal to minus 4 only. This is minus 8, this is minus 4, which will become what? Which will make this resultant to be minus 4. Put this number here. So is equal to minus 27 by 8 into alpha cube plus beta cube, which is what? Minus 4. So what's your answer? Your answer is 27 by 2. 27 by 2. Okay.